Chemical reactions and equations. Introduction. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers, an iron, tawa, pan or nail is left exposed to humid atmosphere, grapes get fermented, food is cooked, food gets digested in our body, we respire. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what's actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Hold it with a pair of tongs, burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in the figure. Burn the magnesium ribbon keeping it as far as possible from your eyes. What do you observe? You must have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. From the above three activities, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of a gas, change in temperature. Take a few zinc granules in a conical flask and add dilute hydrochloric acid to this. We observe that from the surface of the zinc process, a gas is evolved very briskly. Further, if we touch the flask, it is found to be hot. To test the gas evolved, the flask is fitted with a tube as shown. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. Chemical equations. When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen gives magnesium oxide. The substances that undergo chemical change in the reaction, magnesium and oxygen, are the reactants. The new substance magnesium oxide formed during the reaction is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side with a plus sign between them. Similarly, products are written on the right-hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 gives MgO. Count and compare the number of atoms of each element on the left-hand side and right-hand side of the arrow. Is the number of atoms of each element the same on both the sides? If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation is a skeletal chemical equation for the burning of magnesium in air. Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation balanced? Let us learn about balancing a chemical equation step by step. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 gives ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. As the number of atoms of each element is the same on both sides of the arrow, is a balanced chemical equation. Types of chemical reactions. Combination reaction. Calcium oxide reacts vigorously with water to produce slaked lime or calcium hydroxide, releasing a large amount of heat. CaO solid plus H2O liquid gives CaOH2 aqueous. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Formation of slaked lime by the reaction of calcium oxide with water. Touch the beaker as shown. Do you feel any change in the temperature? In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. Decomposition reaction. In this reaction, you can observe that a single reactant breaks down to give simpler products. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. CaCO3 solid, when heated, gives CaO solid plus CO2 gas. Take about 2 grams lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. What do you observe? Note down the change, if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide. The reaction that takes place is 2PbNO3 twice, solid, that is lead nitrate, on heating gives 2PbOS, that is lead oxide, plus 4NO2G, that is nitrogen dioxide, plus O2G, that is oxygen. Let us perform some more decomposition reactions. Take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by bringing a burning candle close to the mouth of the test tubes. Caution: this step must be performed carefully by the teacher. We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. Why does the iron nail become brownish in color and the blue color of copper sulfate solution fade? The following chemical reaction takes place. Fe solid plus CuSO4 aqueous gives FeSO4 aqueous plus Cu solid. Take 3 iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube for about 20 minutes. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Double displacement reaction. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the 2 solutions. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Oxidation and reduction. Take a long glass tube about 2 to 3 centimeters in diameter and 30 to 40 centimeter long. Clamp it horizontally in a camp stand as shown. With the help of a spoon with a long handle, place a teaspoonful of copper powder into the tube. Close both ends of the tube with corks having holes and fit it with tubes as shown. Heat the tube from below with a burner at the point where copper powder is placed. Let the air flow through the tube as shown. Continue heating the tube for about 30 minutes. The surface of copper powder becomes coated with black copper 2 oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. The surface of copper powder becomes coated with black copper 2 oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. 2Cu plus O2 on heating gives 2CuO. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. CuO plus H2 on heating gives Cu plus H2O. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction, the copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation-reduction reactions or redox reactions. CuO plus H2 on heating gives Cu plus H2O. Have you observed the effects of oxidation reactions in everyday life? Corrosion. You must have observed that iron articles are shiny when new, but get coated with a reddish-brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. Rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, that is antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down oxidation. Do you know that chips manufacturers usually flush bags of chips with gas, such as nitrogen, to prevent the chips from getting oxidized?